Hello everyone, we're talking about polymorphism today, and first let's focus on some ideas. First of all, when we call object.method, the method has to be bound with the object, and sort of the choice is made what method will be executed when we call doIt. And it can be done in compile time, but in our case in Java, it is done dynamically, so during the run of the program, during the runtime. And that is called late binding. And this is what really allows for polymorphism here. Now, polymorphism means having many forms, and polymorphic reference or is a variable that can refer to different types of objects at different points of time. And the method called through a polymorphic reference can change from one invocation to the next because the variable itself is pointing to objects from different classes, like a parent class or a child class, as we will see shortly. So all references are potentially polymorphic, and again, reference stands for reference variable. They're a variable that is referencing or containing an address of an object. So when we declare a variable job of the class occupation, it can reference to the object of the class occupation or any subclass, any child class, for example, the college instructor. It would be a child subclass of a job, of occupation. So job can reference any subclass. And when we call a method on this job dot, say, do work, then an appropriate method from the corresponding subclass may be called. Or maybe it's a parent method in case that the parent class method in case where when jobs actually referencing the occupation object. So let us look at two classes here, holiday, which is a superclass of Christmas, and we can use a holiday reference to a Christmas object. So here is the universal modeling language diagram. Holiday day, we are declaring a variable of for an object of holiday class. And day actually is initialized a new object, new Christmas. Christmas being a subclass of holiday makes it fine. So Christmas actually inherits from holiday. You cannot do the other way around. And once we created objects of type Christmas or type holiday, and we have a variable reference in them, we can call variable dot method, and depending on the underlying object referenced by this variable, the corresponding method will be created, will be executed. So in other words, assigning a child object to a parent reference can be performed by simple assignment. Remember how to remember that holiday is a more general parent class to Christmas. Christmas is a holiday, but not all holidays are Christmas. So we want to invoke a method day.celebrate. And depending on what exactly the .celebrate method is calling, because day is a variable, it can be of holiday class, in which case it will call celebrate method of the holiday class, and in the other case it would be if the day references an object of Christmas class, it would be referencing the celebrate method of the Christmas class. And it's important to understand the following. The day can be declared as a holiday variable, and holiday might not have a method get a tree because you don't get a tree, for example, for 4th of July, but you do get a tree for Christmas. So get tree is a method only in Christmas. But because holiday does not have this method, this will be an error even if your day is actually equal to instance of Christmas. And the way to do that, if your day is actually referring to Christmas, but before was declared as a holiday, is to cast first and then call the method. All right. So this is quick question. Pause the video if you like. Music player M player equals to new CD player. Music player is a superclass of CD player, so this is fine. And the second one is not, so that's the answer. All right, let us do our own example. Here we are. So I created the classes, but I did not do anything with them. So we have a class animals. It will be a parent class to cat and wolf. And here is our driver for whatever we want to test those classes on. All right, animals. So animals will have a method public void eat. All right, so public void eat, and I will just make a printing statement here, println. The animal or needs to eat. To eat. And I guess that's all about the class animal for now. And very similar method. First of all, cat so far is not related to animals, and I should say extends animals. And public void eat will say cat eats kibble. And very similarly for wolf, it should extend animals, and it should have the method with the same name. The wolf hunts. Rabbit. So there are 3 eat methods here. One is from the parent class, and the other 2 are in the corresponding subclasses. Now, finally, let us create a few examples. So, for example, cat C equal to cat, and wolf W equals to wolf. Oops, I'm forgetting the new. And new. And finally, let's do the same with animals. Animals a equals to new animals. All right. So this is not polymorphism yet. I just want to test what happens when cat eats or wolf eats and a dot eats. All right. Let's run that. We are waiting for it to run. It's gonna be a little bit. Parsing. And yay. So notice that methods execute as we would expect them. So cat has its own eat method, and animals have the parent class has their own eat method. So far, nothing surprising. Now, however, we are going to change all of the declarations to animals. Oops. Animals, and yet again, animals. Here is polymorphism for you, even though the declaration for each of these variables was animals, it actually knows which method to execute. So it's executing the method, the appropriate method for cat, and so on. So how about I change variable to the same thing? A and another copy of A. And so every time I assign A, I'm going to check what the eat does. So a.eat. And here is an example of a true polymorphism for you. So a.eat, a equals to new wolf or new cat, and the corresponding method executes, even though all of them are actually, the declaration for the variable is animal, so it allows for objects of animal and subclasses. So this is a basic idea of a polymorphism for you, and just to make it a little more interesting, we are going to create an array list. I'm keeping the variables here for now. Actually, I will only need this code. So how about we create an array list? Array list of animals. And this is a new array list. And of course, we're going to add to it now. I need a name for array list. Just call it a list. And now I'm calling list.add. And what are we adding? New cat. Very similarly, we are going to add a new wolf. List.add new wolf. And list.add new animals. And now for int I equals 0, I less than list.length, or size, and I++. So for each of this, we are going to call list dot, or just index on the list, I. List get I. Get I. And on this object, we are going to do it. So see, it's actually proposing to me to do that because it knows that all of these objects will have a method it. All right, so there we go. Let's run this. So it works just the same way. So list.getI fetches the object, and the .it is actually binded dynamically with actually the right method belonging to either superclass or one of the subclasses. And if you like to lighten up this code, animal, animals, animal from list, I can do animal.it. And this is like a perfect example for a polymorphism. We have one variable, animal. It is dynamically referring to different objects of the class animal or subclasses of the class animal, and depending on which object it is referring to, it actually executes the corresponding method.